Hey everyone, and welcome. We are about to go on one of the coolest journeys in tech today, mapping out how you can take a simple idea, just a little spark, and turn it into a real, working AI project.
So, have you ever had one of those light bulb moments and thought, hey, could AI actually solve this? You might think it's some kind of dark art or magic, right? Well, not exactly. There's a really clear, structured path from that initial idea to a working solution, and today we're going to walk that path together.
And this is our map. It's called the AI project cycle. I want you to think of it like the blueprint, the framework that guides creators from a kind of fuzzy concept all the way to a finished AI model. It's the recipe we're about to break down, piece by piece. So, let's dive right into our 5-step quest. Each one of these stages is like a critical checkpoint on our adventure, and each one builds directly on the last, guiding us to our final goal. So here they are, the big 5. First, we have to define our quest with problem scoping. Then we gather our tools and materials with data acquisition. After that, we need to understand what we've got in data exploration. Then comes the main event, modeling. And finally, a step that's absolutely crucial, evaluation, where we see if our work, actually worked. So let's kick things off with step 1. You know, every great adventure starts with a really clear goal. And in AI, this first step, problem scoping, is honestly the most critical one. Because if you get this wrong, you could spend months building a perfect technical solution to a problem that nobody actually has.
But what if you're not sure where to even start looking for a problem? Well, here's a fantastic source of inspiration: the UN's Sustainable Development Goals. Think about huge challenges like zero hunger, quality education, or clean energy. These are massive, meaningful quests where AI could make a huge difference. Now, to turn a big, grand idea into a focused mission, we need a compass. And for us, that's the 4Ws problem canvas. It's a super simple but really powerful tool that makes us ask the 4 most important questions: who, what, where, and why. Okay, let's break this down. Who is all about the stakeholders, the actual people who are affected by this problem. What is where we define the specific problem we're trying to solve. Where gives us the context of the situation. And why, this one's so important. It forces us to really think about why a solution would even be beneficial. Answering these 4 questions is what makes your entire project crystal clear. So once we have our quest locked in, we need to gather our tools. And in the world of AI, the #1 most essential tool is data. Without it, our project just stops. It's literally the fuel for our engine.
But here's the thing. We don't use all our data in the same way. We split it into 2 piles. The big pile, the training set, is like the textbook and all the homework problems we give our model to learn from. The smaller pile, the testing set, that's the final exam. It's brand new data the model has never seen before, and it's how we check if it actually learned the right lessons. And where does all this data come from? Well, pretty much everywhere. You could be collecting answers from surveys, scraping information from websites, or pulling data from sensors and cameras. You can even use things called APIs, which are kind of like pre-built data pipelines from other services, or you could just rely on your own direct observations. Okay, so we've got our bag full of data. Awesome. But before we just dump it into a model, we have to actually read the map. This stage is all about understanding what we've collected, finding any hidden treasures, and, clearing away the thorns and brambles.
And we really do this in 2 parts. First, we have to do some data cleaning to tidy up any mess. Then we use data visualization to actually see the patterns and stories that are hidden inside all those numbers. Clean, then see. So what does messy data even look like? Well, take a look here. See that single point on the left floating way, way out from the main group? That's called an outlier, and it could be a typo or an error. And on the right, those NaN values, that literally means not a number. It's missing data. Cleaning is all about fixing these kinds of issues so our AI doesn't get confused by bad information.
So why do we bother turning clean data into charts and graphs? It's simple, really. Our brains are just built for pictures. A good visualization can show you a trend or a pattern in a split second, something you might completely miss if you were staring at a giant spreadsheet for hours.
So let's do a quick-fire round of 4 of the most common and powerful tools in our visualization toolkit: bar charts, line graphs, scatter plots, and pie charts. Each one tells a totally different kind of story.
First up, the trusty bar chart. This is your go-to for comparing different groups of things. Think, sales numbers for different products, or maybe population sizes in different cities. It makes answering the question, how much for each category, super clear, instantly.
Next, we've got the line graph. This is absolutely perfect for tracking how something changes over a continuous period, like time. You can immediately see the ups and the downs, and it tells a really clear story about trends. Is something growing, shrinking, or just staying the same?
Now, what if you want to see if two totally different things are connected? That's where the scatter plot shines. Each little dot is a data point, and the overall shape they make can reveal if there's a correlation, which is just a fancy way of saying that as one thing changes, the other tends to change in a predictable way too.
And finally, the classic pie chart. This one is all about showing parts of a whole. So whenever you need to see percentage breakdowns, like how a budget is split up or the results of a survey, a pie chart gives you that really quick, intuitive snapshot of all the different proportions.
All right, with our problem defined and our data clean and understood, it's time for the main event, building the model. This is where we actually get to train our AI companion to see patterns and make predictions all on its own.
And there are two main ways to think about this. The rule-based approach is like giving the AI a very strict, detailed instruction manual. If you see X, do Y. But the learning-based approach, that's way more powerful. We just give it the data, and it figures out the patterns and writes its own instruction manual. It actually learns and adapts.
One of the most common ways to do this is called supervised learning. And the name kind of gives it away, right? You're supervising the learning process. To teach an AI to recognize a cat, you don't just show it random pictures. You show it thousands of pictures that are already labeled with the right answer, cat or not a cat. It's exactly like a student studying for a test with an answer key.
And there you have it. That's the roadmap. We've gone all the way from scoping a problem to getting and exploring the data, and finally to building a model. Of course, the very last step would be to evaluate that model with our testing data to see how well it learned. That whole circle is the roadmap. So now that you know the path, the only question left is, what journey are you going to take? What problem in your community is just waiting for an AI solution?